Welcome to Effective Tubing Tools Techniques, Overview and Step-by-Step Instructions. With the largest single line of top-quality, durable HVAC&R tools in the industry, Yellow Jacket is a name professionals like you all over the world have come to trust. This is the third in a series of videos designed to help you work smarter and safer. With this DVD, we offer you the instruction and straightforward how-to knowledge to go along with the tools you rely on to do your job. We hope you'll find this guide beneficial to both you and your business. Now, let's get started. While installing or servicing HVAC&R systems, you'll undoubtedly be required to install or repair the supply and discharge tubing to and from the various system components. Understanding the proper methods for using your tubing tools will help you be more efficient. Plus, when you follow these procedures, you'll prevent harm to both you and your tools while getting the job done right the first time. Before we begin, let's talk briefly about safety. It's important to understand how each tool is designed to function and make sure you have all the right tools in your bag to do every job correctly. Attempting to use a tool in a manner it was never intended may result in personal injury, damage to the equipment, or destruction of the tool. Also, always be aware of the refrigerant you're working with and the state the system is in when beginning your work. You may or may not be required to perform a lockout procedure before doing anything to the system. Finally, be responsible and always wear eye protection as well as a good pair of work gloves when it's appropriate. There are a variety of tools available for you to choose from for every procedure we demonstrate in this video. We'll illustrate how to use the most popular tools for each procedure based on our experience interacting with professionals like you. We suggest you try different techniques before determining your preference. The procedures we'll cover include cutting, deburring, flaring, swaging, and bending. All of the tools we cover in this video are for use with soft copper only, unless otherwise noted. Cutters come in a variety of shapes and sizes. We recommend you have a few different style cutters in your toolbox in order to handle various situations out in the field. It's also a good idea to have spare parts for all your cutting tools nearby. Service kits are available and have all the necessary parts to keep your workflow from coming to a halt. Let's take a closer look at the most popular styles of cutting tools. While there are cutting tools for diameters from 1/8 to 5 1/8 inch tubing, the two most popular styles are similar to this Yellow Jacket Premium Tube Cutter and Heavy Duty Mini Cutter. The Premium Tube Cutter cuts 1/8 to 1 1/8 inch diameter tubing and features wide rollers with a flare cutoff groove. Here's how it works. After marking your cut line, retract the tool's cutting wheel by rotating this feed screw counterclockwise until the opening is large enough for the tube to slip into the jaw of the tool. Line up the cutting wheel with your mark and gently rotate the feed screw clockwise until the tool's jaw closes, just enough to slightly grip the tube between the rollers and the cutting wheel. Now gently turn the feed screw an additional quarter turn so the cutting wheel applies a small amount of pressure to the tube. Don't over-tighten the jaw, or you might damage the cutting wheel and tube. Now slowly roll the entire tool and pay close attention to the score left behind by the cutting wheel. This is your cutting line. From here, continue to gently tighten the feed screw every 2 to 3 times you roll the tool around the tube. Taking your time will help prevent the cutting wheel from jumping your original score line and compromising your cut. As with many of the cutters, the Premium Tube Cutter has a spare cutting wheel tucked away in the handle, so you'll never have to worry about being on the job site without a spare blade. It also comes with a deburring blade, and it can be modified with a blunt wheel to double as a constrictor tool for rolling down or capping off the diameter of your tubing. The second most popular style cutter is like this mini cutter, designed for heavy-duty cutting from 1/8 to 7/8 inch diameter tubing. This tool features a wide body for an easy grip, large rollers, and a flare cutoff groove. The operation of the mini cutter is identical to the Premium Tube Cutter and is especially useful in tight spaces. The key to making the perfect cut every time is a sharp wheel and patience. Without both, you'll most likely get a cut that is either surrounded by multiple score lines or a cut that has partially collapsed the tube. Let's take a look at what over-tightening the tool's grip really does to the tube. Here is a perfect cut, and here's a cut from a tool that has been over-tightened. Notice the thickness of the tube's wall at the point of the cut. This cut has rounded off the end of the tube, and the wall thickness of the tube itself has been compromised and may crack when you flare or swage that end. In contrast, the tube with the perfect cut has its entire wall thickness intact at the cut end. Along with the conventional cutters we've just looked at, there are specialty cutters, such as this innovative tight spot flare cutoff tool from Yellow Jacket. As the name implies, it allows you to get into very tight quarters to remove the flare on smaller size tubing. When you're dealing with an existing application where all you can afford to remove is the flare, this tool is just what you need. Now that the cut is finished, it may be necessary to remove the burrs left behind on your cut. Burrs are the little metal shavings that turn up on the inside wall of your tubing at the cut point. These shavings must be completely removed or they'll compromise the seal and integrity of the entire HVAC&R system. You'll notice far fewer burrs if you use a sharp cutting wheel. This is one of the most popular styles of tube deburring tools. The blade for removing burrs is very sharp, so pay close attention to how you operate this tool to prevent personal injury. Like cutting, it's very important that your deburring tool has a sharp blade. This particular model comes with blades inside the handle. Point the end of the tubing slightly downward. This allows gravity to work in your favor, encouraging the burrs to fall out and away from the tube. If the burrs fall inside the tubing as you remove them, you must take a moment and clear them out before continuing on. While holding the grip firmly, insert the deburring blade into your tube and apply a small amount of pressure between the blade and interior wall. While applying this pressure, rotate the blade around the interior wall of the tube, shaving the burrs off as you go. Remember, the blade is very sharp. Work carefully and keep your fingers away from the blade. Pay attention to whether or not the burr peelings are curling inward or outward as you use your tool. Try to peel them outward so the burrs easily fall out and away from the tube. Notice the burrs will peel up and away from the path of the blade and easily drop out of the tube. Using your deburring tool in this manner makes it far less likely you'll need to retrieve the burrs that fall inside your tubing. Deburring should be a fairly straightforward procedure. If the tube was properly cut to begin with, the burrs should easily shave off and fall away. In the best case scenario, the burrs will require only one pass to remove them, which means less time to complete the job and less chance of an injury. If the original cut was executed poorly, you may find the burrs require far more pressure to remove. Not only does this increase your chance of injury, but it will most likely result in a thin tube wall, which may cause cracking during the flare or swaging procedure. Another popular tool for removing burrs is a tube reamer and burr remover tool. This particular tool removes inner and outer burrs from the cut, and it too requires little force if the original cut was executed properly. Simply place the tool over your cut, again holding the tube at a downward slant, and rotate the entire tool clockwise until the burrs have been completely removed. The premium tube cutter previously demonstrated is equipped with a deburring blade. This particular blade requires a paring method of shaving the burrs and more force. The blade is very sharp, so use caution when performing this procedure. Flaring soft copper tubing allows you to connect tubes to each other or to another type of fitting. Tubing that's been successfully flared has a gradually widening profile. Flaring tools are available in a variety of shapes, sizes, and styles. There are full-range flaring tools, flaring tool kits, flaring tools that also burnish, and specialty flaring tools like the eccentric cone flaring tool. You'll most likely arrive at your own personal favorite through trial and error. It's important to note that flaring tools for tubing are different from flaring tools for piping. Tubing flares have a 45-degree angle, while piping flares have a 37-degree angle. The most popular flaring tool is the bar-type flaring tool. Designed for flaring tubing in tight places, this particular tool can accommodate tubing sizes of 3/16 to 5/8 inches. The tool itself is made up of a hardened steel flaring bar that is designed to grip the tubing. Butterfly nuts at either end of the bar provide the pressure for gripping the tubing. Slide the tubing into the correct size slot and place it at the height you want the flare. Some manufacturers recommend that you set the copper tubing at a specific height for R410A, so be sure to check the manufacturer's installation manual for specifications. Now, tighten down the bar's grip on the tubing. One of the most common mistakes made with this type of tool is in tightening the butterfly nuts. Be sure to first completely tighten the nut that is located nearest the tube. Manually tighten it as much as you can. Now, tighten the other nut, and the bar should have a sufficient grip on the tubing. It's not necessary to tighten until the two bars touch. This is not about brute strength. It's about technique. At any point, if you use a device such as a screwdriver to aid in the tightening, you are misusing this tool. After securing the tube in the bars, the tool's forged steel yoke slips over the bar and locks with a turn. Rotating the precision-threaded feed screw clockwise draws the tip of the tool's cone into the tubing and proceeds to drive the copper into the beveled mating surface of the flaring bar, gradually widening the end of your tubing. You may want to back the cone off once or twice during the process of driving the cone into the tubing. Doing this will help the copper seat nicely to the beveled edge of the bar, as well as burnish the copper for a better seal. It's important to keep the flaring cone clean and the tool lightly lubricated so it continues to operate properly. There are many sizes and styles of bar-type flaring tools, but the technique is always the same. In fact, there are kits available that include different size cones for a given flaring bar. Another flaring tool is a full-range model, like this one from Yellow Jacket, that flares tubing sizes of 1/8 to 3/4 inches. All of the mechanical parts necessary for molding the perfect flare are included. This tool automatically sets the flare height per manufacturer's specifications, including R410A, and features a multifaceted burnishing cone that compresses and polishes the flare simultaneously. To use, adjust both wheels for the size of tubing you're working with. Next, insert your tubing into the tool and rest it on the height stop shown here. This automatically sets your tube to the proper height, a benefit over the bar-type flare, which may require the use of a height gauge. Close the clamping yoke and tighten the butterfly nut. Note the height stop has now moved, making way for the burnishing cone. Start rotating the feed screw clockwise to activate the burnishing cone. Note the polishing effects when you're finished. The last featured product in this section is the eccentric cone flaring tool. This tool resembles the bar-type tool, and even though the eccentric cone operates very differently, it achieves the same result. First, the cone is positioned off-center in the tubing, which is unlike the cones in the previous examples. During the rotation of the large feed screw, the eccentric cone rolls around the inside diameter, creating uniform walls that make up the flare without galling. When flaring for R410A, be sure to check the manufacturer's specifications for flare height requirements, in which case you'll need an additional height gauge. Just as a flaring tool is used to make a flare connection, a swaging tool is used to make a permanent brazed connection. Swaging the end of your tubing is similar to flaring in that your goal is to gradually widen the end of your tube. However, swaging eliminates the use and expense of fittings, as well as the opportunity for leaks. Swaging allows you to increase the inside diameter of the tubing for a short length, so you can slip one tube inside the other before brazing. This graphic shows the difference between a swage and a flare. There are a number of different styles and sizes of swaging tools available, from the traditional punch type to feed screw to tube expander. Many flaring kits also come with swaging bits to turn your flaring bar into a swaging bar. Get to know your options before settling on a personal favorite. First, let's look at the traditional punch type swager. As the name suggests, this tool is designed to punch the end of your tubing. Simply insert the lead end of the punch into the tubing. Make sure the tool is aligned perfectly straight with the tubing. A common mistake is to drive this into the tube at an angle. While gripping the tubing tightly, use a hammer to strike the punch, driving the swager into the end until you reach the stop and have achieved the form you're looking for. Another swaging tool option is the feed screw swager. This particular kit can be used for both flaring and swaging. To begin, outfit the feed screw with the proper size swage bit, and then retract the feed screw out as far as possible. Next, check the tube grips on the bar. The grips can get filled with copper, and cleaning the copper out will ensure that the tube doesn't slip. Insert the tubing into the bar, extending it through the bar farther than you would for a flare, as a swage requires more depth than a flare. Position the yoke and swage tip on the bar over the tube. Slide the tube up to the bottom. This is the position the bars need to be in before the butterfly nuts are tightened. Remove the yoke to prevent injury, and then tighten the bar starting with the butterfly nut closest to the tube. Tighten the second nut. Tightening the butterfly nuts for a swage is a little more critical due to the amount of force required to forge a swage. So after tightening down the second nut, it might be helpful to back it off a bit and go back to the first nut and tighten it a bit more. Return back to the second nut again and tighten it down. If the tube slides during the swaging process, repeat this back and forth tightening to improve the grip on the tubing. But remember, always tighten down the butterfly nut closest to the tubing first. It's also a good idea at this point to use just a tiny amount of lubricant between the swage bit and your tubing. Not enough to contaminate your braze joint, just enough to offer a little lubrication, especially if you've performed a lot of swages with your bit. The only thing left to do is feed the swaging bit into your tubing. During this part of the procedure, if you notice the tube is slipping in the bar, back out the bit and retighten your bar. Allowing your tubing to slip around will ultimately render your bar useless. While your bit is entering your tubing, note whether or not you've extended the tube out past the bar enough. If your tube is set to the proper height, your swage won't bottom out on the bar. Another option is the tube